solve the following linear programming problem using graphical method. So this is an easy method. Anyone can solve the particular problem. Most of the times the problems are given in the examination on the lines of graphical method or on the lines of this particular simplex method. Now this is maximize z is equal to 6x1 plus 8x2 subject to the constraints 5x1 plus 10x2 less than 60, 4x1 plus 4x2 less than 40, where x1 and x2 always greater than 0. So in the graphical method, the introduction of non-negative constraints, the x1 greater than 0 and x2 greater than 0 will eliminate the second, third, fourth quadrants of x1 and x2 plane as shown in the figure 2.1. Now we compute the coordinates of x1 and x2. Compute the coordinates of x1 and x2. What x1 plane from the first constraint. So if x1 is equal to 0, if x1 is equal to 0, x2 is equal to 6. 60 by 10, automatically 6. Similarly, if x2 is equal to 0, if x2 is equal to 0, x1 is equal to 12, 60 by 5. So plot the first constraint as shown in the figure 2.1. So this is next comes to second constraint, that is 4x1 plus 4x2 is equal to 4. If x1 is equal to 0, x2 is equal to 10. And similarly, if x1 is equal to x2 is equal to 0, automatically x1 is equal to 10. Both x1 and x2 10. Therefore, the coordinates are nothing but 10, 10. Whereas in this particular case, 0, 6 and 12, 0. So this is the way you are going to get the coordinates. Now this you can see this particular thing. The enclosed polygon ABCD is the feasible region. The objective function value at each of the corner points of the closed polygon is computed by substituting its coordinates in the objective function. So ZA is equal to this thing. You go to this particular problem. So this is the particular problem. The first line 10, 10. So this is 4x1 plus x2. If x1 is equal to 0, x2 is equal to 10. If x2 is equal to 0, x1 is equal to automatically 10. So 10 is marked in this particular x line. So you see this horizontally, this is x1. So x2 is nothing but a y coordinate and is also marked. Therefore, this is a 10, 10 point line 4x1 plus 4x2 less than or equal to 40. This line corresponds to the second constraint. Whereas first constraint, this is nothing but 0, 6 and 10 comma 0, 10 comma 0 this is. And if you substitute the, this is the coordinates, if you draw the particular line, this is nothing but 5x1 plus 10x2 less than or equal to 60. He has already shown it. He has already shown it. So like this, both the equations are tend to be less than or equal to 0. Hence, if you hatch this below, less than means below this particular thing. And if you hatch this below this particular length, so like this is a feasible region. Now this is A origin, B, C, D like this. I told you to draw it on the particular graph sheet, thereby try to identify the particular points. So this corresponds to 8 and this corresponds to 2. Therefore, automatically it will become 8, 2. And this becomes 0, 0, A, and whereas B becomes 10, 0, and D becomes 0 and 6. 0 and Y is nothing but 6. Here X is equal to 10. So therefore 10, 0, this is 0, 6, and this is nothing but 8, 2. The 4 points in between this is a feasible region. And if you substitute this, and what is the maximization equation? Maximize Z is equal to 6x1 plus 8x2. So you have to substitute all the ABCD points in this particular equation. So if you go to this particular point ZA, A point, nothing but I told you that is 0, 0, 6x1 plus 8x2, automatically it will come to 0. So next comes to, again, second point. Second point is nothing but 10, 0. So therefore 6x1 plus 8x2, automatically it comes to 0. Similarly, at a point that's 8 to 6x1 and 8x2 is equal to automatically 64. So in all the cases, it is 64 is the maximum. There, Z maximum is equal to 64, and the value of the objective function is nothing but 64. Like that, you have to mention. So this is the way you have to identify the particular thing. You have to identify the particular. So here, x1 is equal to 8, x2 is equal to 2, z is equal to 64. Since the type of the objective function here is maximization, the solution corresponding to the maximum z value is to be selected as the optimum solution. So we have calculated the z value at 4 points. At 4 points, that is A, B, C, D. So this is 0, 0 means automatically 0, and this is 10, 0, and this is nothing but 0, 6, and this is 8, 2. Automatically, you are going to get, because 8 is there, 2 is there, and automatically you are going to get this 64 as the maximum value. And this is that value is maximum for the corner point C. Hence, the corresponding solution is presented below. That is where x1 is equal to 8, x2 is equal to 2. The z maximum is equal to, or z max is equal to 64. Like that is the solution for the particular ring. Next, solve the following LP problem using graphical method. Using graphical method, this is another problem. Minimize z is equal to 2x1 plus 3x2. 2x1 plus 3x2 subject to the constraints x1 plus x2 greater than 6, 7x1 plus x2 greater than 14. So there are two equations which are greater. And previously the equation is nothing but it is lesser, and here this particular case is nothing but greater than, where x1 and x2 always greater than 0. So introduction of the non-negative constraints will eliminate the second, third, fourth quadrants of x1 and x2 plane as shown in the figure 2.2. Now we compute the coordinates of the plot. To plot on the x1 and x2 plane relating to different constraints from the first constraint x1 plus x2. So x1 plus x2 is equal to 6. x1 plus x2 is equal to 6. And if you put x1 is equal to 0, x2 is equal to 6 automatically. And if x2 is equal to 0, automatically x1 is equal to 6. So it means 0 and 6 are the first ordinates, and 6 and 0 are the next points. So this is the way you have to find out the ordinates by putting x1 is equal to 0 and x2 is equal to 0. Like that, you are going to get the 2 points. Next comes to, similarly, second constraint is 7x1 plus x2 is equal to 14. 7x1 plus x2 is equal to 14, and 7x1 plus x2 is equal to 14. Therefore, if you put x1 is equal to 0, x2 is equal to 14, and x2 is equal to 0, x1 is equal to 2. So like that, you have to identify the coordinates for this particular thing. So x1 is equal to 0 means x2 is equal to 14, x2 is equal to 0 means x2, 1 is equal to 14 by 7, 1. So like this, now this you have to find out the coordinates, identify the, you have to draw the lines for the, with the help of the coordinates. So this is this line corresponds to 7x1 plus x2 is greater than 14, and x1 plus x2 greater than 6. So this is if you put x1 0, x2 is equal to 6. If you put x2 0, x1 is equal to 6. Therefore 0 6, 0 6 and 6 0 are the 2 points. So this is the line what you are going to get. Whereas in the previous case it is nothing but 14 0 14 0 14 on the y axis, 14 0, and on this particular case it is 2 and 0. Automatically you are going to get the particular thing. So this is the way we are going to get the particular thing. Now these are the two lines, both are meeting at a particular point. So in this case, it is above the greater than means you have to hatch above the line. And here also you have to hatch above the line. And therefore this entire region is going to be the feasible region. So therefore, so like this, after getting the particular thing, you have to calculate this particular point where it is intersecting. So one is this particular D, second one is C, and third one is nothing but B. And this is the way you have to identify the 3 points. So if you draw a horizontal line here, a vertical line here, automatically you can find out the coordinates. 4 by 3 and 14 by 3. 4 by 3 and 14 by 3. So automatically you are going to get this particular thing. Unless you have the graph sheet, you cannot draw these particular things. Try to practice at your house on a graph sheet. So you can understand well with this particular thing where it's very clear. Now A, B, C, D, E is a feasible region. The optimal solution will be in any one of the corner points B, C, D. B, C, D. I told you B, C, D. The objective function value at each of these corner points is computed as follows. So this is ZBCD. So this is BCD. Where is BCD? Is B, C, D. And this is D points are nothing but 6 0 is 4 by 3, 14 by 3. And this is nothing but and 0 14, 0 14. So 0 14, 0 and 14, x1 and x2. So 0 14, if you substitute, it is going to get 42. And next thing is nothing but 4 by 3 and 14 by 3. X1 is equal to 4 by 3, x2 is equal to 14 by 3, and you are going to get 50 by 3, 16.67. Next comes to, that is x1 is equal to 6, and x2 is equal to 0, that is 6 and 0, automatically you are going to get the 12th. And after this, what is this maximization function? Since the type of objective function is minimization, it is not maximization, it is minimization. So you go to this particular top, automatically you can find out. Solve the following problem using graphical method, minimize is given. So because it is a minimization problem, minimum of the z you have to select, minimum of the z. Previously it is a maximization problem, and we are going to get this particular thing. So therefore, minimum value is nothing but the z value is 12, and 12 is occurring at 6 0 6 0. Automatically, since the type of the objective function is minimization, the solution corresponding to the minimum z value is to be selected as the optimum solution. That value is minimum for the corner point D. Hence, the corresponding optimum solution is x1 is equal to 6 and x2 is equal to 0, where z is equal to 12. So here it is minimum, and all these things are nothing but the maximum values.
Hello, my testing 1, 2, 3.
So z is equal to 12. Is the solution for this because it is a minimization problem. There are two problems what we have solved so far. One is nothing but greater than, less than or equal to, that is maximization problem. Second problem is minimization problem, where the constraints are greater than or equal to. If greater than or equal to is given automatically, and greater than or equal to is given automatically, the feasible region you have to hatch above the particular lines. And if it is less than or equal to, constraints are less than or equal to, and you have to hatch below the line. So these are the important things one should remember. So when you got the particular points, after that the feasible region is surrounded by B, C, and this is particularly D. And so substitute all the points in the maximization or minimization function, whatever it may be. And you are, this is because it's a minimization function, you are going to get, this is 12 on this. That is the objective function value is that is nothing but 12, and the optimum solution is nothing but x1 is equal to 6, x2 is equal to 0, and where that is equal to 12.12. So next comes to is another problem. Solve the following linear programming problem using graphical method. Again, maximization problem, that is equal to 100x1 plus 80x2, 5x1 plus 10x2 less than or equal to 50, 8x1 plus 2x2 less greater than 16, and 3x1 minus 2x2 greater than 16. In this, one equation is less than and two equation constraints are greater than. Now it is that previously one is maximization, second one is minimization. In the maximization problem, all constraints are less than or equal to, and in this all constraints are not greater less than, not greater than. This is the maximization, but there is a greater than is there. So this is a typical graphical method problem. So one should understand very carefully. In graphical method, the intersection of non-negative constraints will eliminate the second, third, fourth quadrants of the x1, x2 plane as shown in the figure 2.3. So therefore, you have to identify the, so if you put the x1 is equal to 0 and x2 is equal to automatically 5. And if x2 is equal to 0, x1 is equal to automatically 50 by 5, 10. So like that, you have to identify the coordinates. Similarly, if x1 is equal to 0 and x2 is equal to 8, and if x2 is equal to 0, x1 is equal to 2. And similarly, if x1 is equal to 0 and x2 is equal to, and this is nothing but minus 3. And if x2 is equal to 0, x1 is equal to 2. So like this, you have to find out the ordinates. If x1 is equal to 0, how much the ordinate? And if x2 is equal to 0, what are the points? And like that, you have to identify all the points for this. With the help of the particular points, you have to draw the lines. You have to draw the lines. Here, you can see that x2, if x1 is equal to 0, x2 is equal to how much? Minus 3. 6 by minus 2, automatically minus 3. So hence it has gone, third equation. Minus 3, it has gone. Minus 3, and this is nothing but plus 2. So like this, he has marked and he has gone up. And similarly, this is equation 2, and this is nothing but equation 1. So in the equation 1, so this line corresponds to equation 1. You see this particular. equation 1. After marking the particular points, all those things, equation 1, equation 2, equation 3. Equation 3 minus. So if you check up this particular equation 1, I told you, if x2 is equal to 0, x1 is equal to how much? 10. X1 is equal to 10 means on this particular case, x1 is equal to 10 marked here. And similarly, if x1 is equal to 0, x2 is equal to 5. And automatically 5 is marked here. So like this, if you draw the particular line, this corresponds to first equation. And this corresponds to second equation, this corresponds to third equation. So after this, what happened? The first equation, first constraint is less than or equal to 50. First equation corresponds to less than or equal to 50. Automatically, you have to hatch below this particular line. And a second equation, and it is greater than. It is greater than means this is the second equation, and it is greater than means because it is the negative side, it will come down. It will come down, and second equation is also 8x1 plus 2x2 greater than 16. So this is nothing but second equation. Greater than means if you hatch above this particular line, all these things, everything has to be hatched above this particular line. So, and therefore, this is the only region. Hatch above means, and this is below means it does not come. And this the area does not come. And hatching below this area will come. Hatching above this area will come. That does not, both are crossing, above and below. Therefore, this region does not exist. But there is another line, and where you can join this particular link. Therefore, this is going to be the feasible region. So one must be very careful to identify this feasible region. And therefore, this is point A, point C, point B. These are the 3 points. So this is nothing but 2, 0, and this is 4, 3, and this is 10, 0. Like this, you have to find out the points. You substitute the values. You substitute the values in the particular thing. X2, previously it is nothing but what I told you. If x1 is equal to 0, x2 is equal to 5. x2 is equal to 0, x1 is equal to 10. And similarly, second constraint, it is x2 is equal to 0, x1 is equal to 2. And if x2 is equal to 0, x1 is equal to x2 is equal to 0, x1 is equal to 2. Like that, you got all the points and what we have substituted and what we got on the particular graph. After that, you have to substitute. This is the closed polygon is ABC. The closed polygon is ABC. ABC. ABC points are nothing but, A is nothing but 0, 2. Sorry, 2, 0. And this is 10, 0. And this is nothing but 4, 3. If you substitute all the points, this is 2, 0. And this is 10, 0. And this is 4, 3. And you got these particular points. So since the type of objective function is maximization, so maximization means you have to find out the maximum value in this particular case. 1000 is the maximum value, and therefore for this the ordinates are nothing but x1 is equal to 10 and x2 is equal to 0. x1 is equal to 10 and x2 is equal to 0. So automatically like that we are going to carry out the particular things. So this is another thing, simplex method linear programming problem. Simplex method is the basic building block for all the other methods. This method is devised based on the concept of solving simultaneous equations. It is demonstrated using a suitable numerical problem. So here there is a particular problem. Try to understand carefully. Consider the linear programming model of example 2.2 and solve it using the simplex method. Maximize z is equal to 6x1 plus 8x2. subject to 5x1 plus 10x2 less than or equal to 60, 4x1 plus 4x2 less than or equal to 40, and 40. And this is the same equation what we have taken in the particular problem. X1 is to greater than 0. So this was solved earlier by graphical method. Now we are also solving the same problem by simplex method. So the standard form of the above linear programming is shown below. Maximize z is equal to 6x1 plus 8x2, 0s1 plus 0s2. Because both are less than constraints. The constraints are less than or equal to constraints. And you have to add the slack variables to remove the particular inequality sign. So this for first equation plus s1, and for the second equation plus s2, and automatically 5x1 plus 10x2 plus s1 is equal to 60, 4x1 plus 4x2 plus s2 is equal to 40. And where s1 and s2 are slack variables which are introduced to balance the constraints. The canonical form is the form in which each constraint has a basic variable. And next comes to definition of the basic variable. A variable is said to be a basic variable if it has unit quotient in one of the constraints and zero quotients in the remaining constraints. A variable is said to be basic variable if it has unit quotient in one of the constraints and zero quotient in the remaining constraint. If all the constraints are less than or equal to type, then the standard form is to be treated as the canonical form. The canonical form is generally used to prepare the initial simplex table. The initial simplex table of the above problem is shown below. So the canonical form is nothing but the form of the equations by adding the surplus variables or slack variables, whatever it may be, plus s1 plus s2 like that. Now this is the tabular form initial simplex table. So the CBs, all those things, S1 and S2 values, basic variable CJ, and this is ZJ, CJ minus ZJ. So this is 6x1 plus 8x2 plus 0s1 plus 0s2 like that. Next comes to this x1, x2, s1, s2, and the first equation is 5x1 plus 10x2. 5x1 plus 10x2, 4x1 plus 4x2. So 4x1 plus 4x2, and s1 and s2, and this is 60 and 40. Now you calculate this particular thing. Therefore, you see this particular problem. You have to calculate Zj after formulating like this. Zj means 0 into 5, 0, 0 into 4, 0, and 0 into 10, 0, 0 into 4, 0, 0 into 1, 0, 0 into 1, 0. Like this, you are getting all the things, all the zeros. Zj is 0. All the Zj values are nothing but 0 because the values of the coefficients are nothing but zeros. And therefore, Cj minus Zj. Cj minus Zj is nothing but 6 minus 0, 6, 8 minus 0, 8, and 0 minus 0, 0 minus 0, automatically 0. And because this is a maximization problem, maximum positive value is nothing but 8, maximum positive value. This is what we are going to call it as entering column. In the entering column, these are the variables, entering column variables. So this 10 and 4 are there, and you 10 and 4 divide this particular 60 by 10, 60 by 10. All these variables, they have to divide this particular the values of the equations, the values of the constraints. 60 by 10, nothing but 6, and 40 by 10, 40 by 4, it is nothing but 10. So smallest ratio you have to select. 6 is the smallest, hence this is the entering row, what he has marked with the 2 stars. This is entering row, and therefore 10 he has blocked it in a square block. So 10 is going to be called the nothing but the key element, what we are going to call it as. he has marked single star. Single star means key column. Double star, it is nothing but the key row, and key column and key row where they are meeting, it is nothing but the key element. This key element has to be converted into 1, and this is nothing but the other element is going to be converted into 0, and therefore when this is being converted, S1 will go out, 0 will go out, and this X2 will come here, and 8 will come here automatically. 8 will come here. In the next iteration, you see this automatically. You need not bother about all these things. So 8 is there, 0 is there, X2 is there, I told you. So if you divide the entire equation by 10, you are going to get half 1, 1 by 10, 0. And that 60 by 10 means automatically you are left with 6. 60 by 10 in the previous equation. 60 by 10. So 60 by 10. So 5 by 10, 10 by 10, 1 by 10, 0 by 10, 60 by 10. And this is nothing but the X2 will come occupy, and this is value is nothing but 8. Like that, things are going to be carried out. So next, after this thing is over, after the things are over, again, you have to convert into this 0 means this new row 2. New row 2 is equal to, new row 2, you have to write here, new row 2 is equal to old row 2, previous row 2, minus 4 into this new R1, minus 4 into this new R1, minus 4 into new R1. So you go to this particular problem. Here it is a 4 is there, and this is 1 is there. So this should be 0 means minus 4 into this new row 1 automatically gives you this particular or 0 automatically. And if you apply this particular equation, if you apply the concept, new row 2 is equal to old row 2 minus 4 into new row 1, minus 4 into new row 1. Old row 2 minus 4 into new row 1. If you apply this particular line, you will get this particular line. Now after this, getting this particular thing, try to calculate ZJ. ZJ means this is 8 into half. It is 4. 0 into this 0 gabatti, we cannot calculate. So 8 into 1, you are going to get 8. 0 into 0 plus. Automatically you are going to get 8 only. Next, 8 into 1 by 10. 8 into 1 by 10, automatically 8 by 10, it is nothing but 4 by 5. And 8 into 0, and 0 into 0, all these things are to be zeros. Actually 8 into 1 and 0 into 0, it will come as 8. So 8 into half, nothing but 4, and plus 0 into 2, 0. So like that, only 4, 8, 4, 5 you are going to get. So this is the values judges. Cj minus Zj means 6 minus Cj, 6 minus 4, it is nothing but 2. Next, 8 minus 8, automatically 0. And this is 0 minus 4 by 5, it is minus 4 by 5. 0 minus 0, 0. So like this, we got the value Cj minus Zj. So among this 0, negative, 0, and 2 is the only positive value. He has marked as single star. It is nothing but the key column. And key column, the variables are nothing but the half and 2. Half and 2. Here 6 divided by half, it is becoming 12. And this is 2, 16 by 2, automatically it is 8. And therefore 8 is the smallest ratio. And this is the entering a row, what we are going to call it as double star. He has marked it. So this is therefore entering column, entering row. Horizontally it is entering row, and this is entering column. This is the key element 2. Key element 2. So this is after this is over, key element, this has to be converted into 1, and this half has to be converted into 0. This has to be converted into 1. This has to be converted into 0. So to make this 1 by 1 and divide this entire equation by 2. And while doing that, this in the next iteration, x12 will come and occupy S2. X1, this x1 will come and occupy S2. and 0 is going to be occupied by 6, and S2 and 0 will go out, and this X1 and 6 will come and occupy. X1 will come and occupy. So divide this 2 means 2 by 2, 0 by 2, and minus 2 by 5 by 2 is 1 by 2, and this is nothing but 16 by 2, 8. It will come like that. So therefore, this the next thing is nothing but you see this 0, 1, 1, 0. You are going to get that J is this much values 8, 6, 8 into 0, 6 into 1. This is 8 into J1 and 6 into 0. Like that, you are going to get the values. So while doing this, the Cj minus Zj values. Cj minus means 6 minus 6, 0, 8 minus 8, 0, and 0 minus 2, 5, minus 2, 5, and 0 minus 1, minus 1. So all the Cj minus Zj values are either 0 or negative, or either 0 or negative, and automatically you can stop the problem at this particular point. You can stop the problem at this particular point. Now you try to identify this particular thing, and whereas x1 is equal to 8, x1 is equal to 8, and x2 is equal to 2, x2 is equal to 2. So like that, the values, the objective function in the tablet 2.14, all the values of Cj minus Zj are either 0 or negative, or either 0 or negative, or either 0 or negative, and automatically, hence the optimality is up to reach. The corresponding optimal solution is as follows. X1 is equal to 8 units, x1 is equal to 8 units, and x2 is equal to 2 units, and the Z value is nothing but 64. So you calculate Cj minus Zj, automatically it is coming like this, or else you calculate, put the values in the starting equation where the maximization equation is mentioned, and if you do that, automatically it will come as 64. So now you have to stop this particular thing. This is a very simple to understand, simple problem, and one can solve easily. So next comes to, this is solve the linear programming problem using simplex method. Maximize Z is equal to 10x1 plus 15x2 plus 20x3, and subject to the constraints 2x1 plus 4x2 plus 6x3 less than or equal to 24, 3x1 plus 4x2, 9x2 plus 6x3 less than or equal to 30. Both our constraints are less than, and it is a maximization equation. And for this, you add S1 and you add S2, and automatically standard canonical form. What we are going to call it as standard canonical form is nothing but maximize Z is equal to same, it will remain the same. And for this 0s1 plus 0s2 plus 0s3, and you have to write like that. And this is subject to the constraints 2x1 plus 4x2 plus 6x3 plus s1 is equal to automatically 24 plus s2 is equal to 30, and to remove the particular. So this what we are going to call it as the here he has here all the constraints are less than type. So the canonical form is given linear programming. So you need not write all these things. So directly you can maximize that is equal to 10x1 15x2 plus 20x3 plus 0s1 plus 0s2. So plus s1 plus s2. So this is going to be called as the canonical form of the given objective function, given problem. So the initial template simplex table of the above problem is shown in the figure 2.15. That in the table, all the values of Cj minus Zj are not less than or equal to 0. Hence, the initial solution is not optimum. The variable x3 is entering the variable because the column with respect to this variable has the highest Cj minus Zj value. So here, whatever it may be, you leave it all those things. You create the table 10x1 plus 15x2 plus 20x3 0s1 plus 0s2. So this is the first thing. x1, x2, x3, s1, s2. And this is 2x1 plus 4x2 plus 6x3 plus s1 is equal to 24. Next 3x1 plus 9x2 plus 6x3 plus S2 is equal to 30. So this is S1 and S2, both are zeros. Now you calculate judges is 0, 0 all there, 0 into 2 plus 0 into 3, 0 automatically, 0 into 4 plus 0 into 9, 0 automatically. Therefore, Cj minus Zj is a 10 minus 0, it is 10, 15 minus 0, 15, 20 minus 0, it is 20, and 0 minus 0, 0 minus 0, it is coming like this. Now you come to this, in all the things, maximum positive value is 20, and this is nothing but the entering column. In the entering column, there are variables are 6 and 6, and 24 by 6, it is 4. 24 by 6, it is 4, and 30 by 6, it is 4. Sorry, 30 by 6 is nothing but 5. So therefore, 4 is the smallest ratio, and therefore this is the entering row, entering column, and 6 is the key element, and you have to make it 1, and you have to make it 0 here. You have to make it 1 means automatically you see this x3 will come and occupy S1, and 20 will come and occupy 0 in the next iteration. So therefore 20 x3, and this is divided by 2 by 6, 4 by 6, 6 by 6, 1 by 6, 0 by 6, 24 by 6. You are going to get 4 here in the next equation. Next comes to this equation has to be turned into a new equation. I told you this is 20x3. This is x3 and 20. You got it. Next, this is nothing but 2 by 6 means 1 by 3. 4 by 6 means 2 by 3. So this is, you see this particular 1 by 3, 2 by 3, 1, 1 by 6, and 4 values. Next comes to row 2. New row 2 is equal to, this new row 2 has to be obtained, and such that this has to be 0. New row 2 is equal to old row 2. Old row 2 means this is the old row 2. Old row 2 minus 6 into new row 1 minus 6 into this new row 1. With respect to this new row 1, you have to calculate, or else you will not get. So it is everybody will confuse at this particular point. Here you have to write new row 2 is equal to, here new row 1 is equal to old row 1 divided by 6. Old row 1 divided by 6, automatically you are going to get this thing because you have to get 1. And this new row 2 is equal to old row 2 minus 6 into this new row 1. This new row 1 minus 6 into 1 means, and minus 6 into plus 6. Automatically it will become 0. This new row 2 will come in this particular fashion. Now comes to this, you have to calculate Zj value. 20 into 1 by 3 plus 0 into 1. 20 into 1 by 3 means automatically 20 by 3. 20 into 2 by 3. 20 into 2 by 3, 40 by 3 plus 0 into 5. Automatically 40 by 3. 20 into 1, automatically 20. 20 into 1 by 6 is nothing but 20 by 6, 10 by 3. 20 into 0, automatically the 0. And like this, you have to calculate. Cj minus Zj means, and 10 minus 20 by 3, 15 minus 40 by 3, 20 minus 20, 0. All these things you have to calculate. In the next iteration, and this is 10 by 3 maximum, 5 by 3, and among all the things 5 by 3, 10 by 3 is maximum value, and this is the entering column, and 1 by 3, 1 are there, 4 by 1 by 3, 6 by 1, 6 is the least ratio, and therefore, and this is the key element, this you should make 1, this you should make 0. It is already 1 because therefore you repeat this entire equation here, and you make it 1 means new row 1 is equal to old row 1 minus 1 by 3 into this new row 2, like this you are going to get this particular thing. So automatically Cj minus Z, you are going to get 20 and 10. So because this x1 will come and occupy, this 10 will come and occupy. 20, 10 and x3 and x1. x3 and x1, 20, 10 and all these things. Like this you are going to get Zj values, all those things. So, and therefore you are going to get the maximum value 100, where x1 is equal to 6, x3 is equal to 2, and x2 is equal to 0. x2 is equal to 0, x3 is equal to 2, x1 is equal to 6. So you 2 values. So like this, you have to calculate the values of this particular thing. So I'm winding up this particular thing. This particular chapter will meet in the next class. Thank you.